I really like this quote. "One day, sir, you may tax it." And that was Michael Faraday, a scientist, responding to Mr. Gladstone, the British Chancellor of the Exchequer, which is basically, like the funding source. And they were like, what good is this research that you're doing? He says, one day you can tax it, right? And I really like this because it illustrates that we need basic science research just for science sake, just to find out new things, because you never know what is going to change the world, right? So electricity, when they first discovered it, stupid, electrons move from one thing, who cares, right? Well, we care, right? So I really like that one. Let's talk about lightning. There was some lightning yesterday. I'm not going to test you on lightning, so you can just listen. So lightning is just a really dramatic demonstration of the power of electricity, right? And batteries work on similar properties. The driving force for lightning and batteries is exactly the same. And that's this. Electrons flow away from negative charge and toward positive charge. So opposite charges attract each other like north and south poles of a magnet. Like charges repel each other. And that's why batteries work, and that's why lightning happens. Couldn't we just stop there? Oh, there's a lot more to it. So how do we get separation of charge for lightning? So in thunderclouds, there's air currents and causing the water particles, little water droplets, and the ice particles to move around and bang into each other. And sometimes when that happens, electrons get knocked off of molecules. So then you have a positive and a negative charge. You've got the negative electrons that go sit on something else, and you've got the positive, right? So the positive charges build up in the ice crystals, and those tend to go towards the top of the cloud, and the negative charges tend to build up on the water, the liquid part, which is in the bottom of the cloud, the slushy bottom, as it says. And so that charge separation is going to stay there until there is some way for it to flow from one to the other. And eventually it will make its own path by ionizing the air. And so then the negative electrons will rush towards the positive charges, and it's very violent, right? We see this big flash of light, and then later we hear the sound. If you've ever been near a sky-to-ground lightning strike, it's fearsome. It really is fearsome. So a lot of lightning is just within the clouds, right? But when the clouds are close enough to the earth and the charge builds up enough, it can actually discharge to the earth instead of to the upper part of the cloud. And so you get a channel of ionized air forming. And electrons flow with a lot of energy. Any questions about lightning? Yes?
What's ball lightning?
What's ball lightning?
Have you ever seen it?
I have heard of it. I do not know.
Okay.
Yeah. Any other questions? Okay, so how are batteries like lightning? Battery has two different substances in it that have different affinities for electrons. One really wants the electrons more than the other one does. And we separate those two substances. One will develop a positive charge, the other develops a negative charge. And if we give them a way to equalize that charge, like by connecting them with a wire, the electrons will flow through the wire. Instead of just doing that, we connect something to the wire, like a cell phone or a light bulb or something. And so as the electrons go through the wire, they do electrical work for us, and then they continue on their way. We're going to learn more about batteries. Any questions right now?